In this video, we are going to learn when the multiplication of two matrices exists, how matrix multiplication is defined, examples where we can find multiplication of matrices, and properties for matrix multiplication. Now, condition for matrix multiplication: the product A times B of the matrix A and B exists only if the number of columns in matrix A is equal to the number of rows in matrix B. If I write the condition in short, where the number of columns in A is equal to number of rows in B, then the product A cross B exists. If A is equal to the matrix of order m cross n, where m are rows and n are columns, and B is equal to the matrix of order n cross P, where n are rows and P are columns. Now number of columns in A are n and number of rows in B are n. Then A cross B matrix is exist and has the order m cross P, where number of rows in AB is same as number of rows in A and number of columns in AB is same as number of columns in P. Let's take an example where A is equal to the matrix 1, 2, 3, 4, 5, 6 of order 2 cross 3 and B is equal to 1, 2, 3, 4, 5, 6 of order 3 cross 2. Now number of columns in A is same as number of rows in matrix B. Therefore A cross B is exist and has the order 2 cross 2. If I take another example, let C is equal to 2, 3, 4, 5, 6, 7 has the order 3 cross 2 and D is equal to 1, 2, 3, 4, 5, 6 has the order 2 cross 3, where number of columns in C is equal to number of rows in D. That means C cross D matrix exists and has the order 3 cross 3. Let's take one more example. E is equal to 1, 2, 3, 4 has the order 2 cross 2 and F is equal to 1, 2, 3, 4, 5, 6 has the order 2 cross 3. Now number of columns in E is equal to number of rows in F. That means E cross F is exist and has the order 2 cross 3. Let G is equal to 1, 2, 3 has the order 3 cross 1 and H is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 has the order 3 cross 3. Then the number of columns in G is not equal to number of rows in H. That means G cross H is not exist. Now let's find how actual multiplication is defined. If A is equal to Aij m cross n matrix and B is equal to Bjk n cross P matrix, then their product AB defined as AB is equal to Cik m cross P, where Cik is the sum of multiplication of corresponding element from ith row of A and kth column of B. Let A is equal to 1, 2, 3, 4, 5, 6 and B is equal to 1, 2, 3, 4, 2, 1. Now A has the order 2 cross 3 and B has the order 3 cross 2. The number of columns in A is equal to number of rows in B. That means A cross B is exist and has the order 2 cross 2. This matrix is 2 cross 2. Then the element of the matrix are, let C11, C12, C21 and C22. C11 represent the element from first row and first column. C12 represent the element from first row and second column. C21 represent the element from second row first column. C22 represent the element from second row and second column. Now let's find this element. Now let's calculate C11, which is multiplication of first row in A to first column in B, which is 1 into 1 plus 2 into 3 plus 3 into 2 equal to 1 plus 6 is equal to 13. Now C12, which is multiplication of first row to second column, which is 1 into 2 plus 2 into 4 plus 3 into 1 equal to 2 plus 8 plus 3 is equal to 13. Now let's calculate C21, which is multiplication of second row in A to first column in B. Now 4 into 1 plus 5 into 3 plus 6 into 2, which is 4 plus 15 plus 12 is equal to 31. Now C22, which is multiplication of second row to second column, which is 4 into 2 plus 5 into 4 plus 6 into 1 equal to 8 plus 20 plus 6 is equal to 34. Now A into B matrix is C11 is 13, C12 is also 13, C21 is 31 and C22 is 34. Let A is equal to 1, 2, 3, 4 and B is equal to 2, 0, 1, 3. Now A has the order 2 by 2 and B has the order 2 by 2. Now number of columns in A is equal to number of rows in B. Therefore A cross B matrix is exist and has the order 2 by 2. If the matrix is 2 by 2, then their element are C11, C12, C21, C22. Now let's find C11, which is multiplication of first row in A to first column in B, which is 1 cross 2 plus 2 cross 1, which is equal to 2 plus 2 is equal to 4. Now C12, which is multiplication of first row in A to second column in B, which is 1 2 2 0 3. Now 1 into 0 plus 2 into 3, which is 0 plus 6 is equal to 6. Now C21, which is multiplication of second row in A to first column in B, which is 3 cross 2 plus 4 cross 1, which is equal to 6 plus 4, which is 10. Now C22, which is multiplication of second row in A to second column in B, which is 3 cross 0 plus 4 cross 3, which is equal to 0 plus 12 is equal to 12. Now A cross B is given as 4, 6, 10, 12. Now third example, let A is equal to 1, 2, 3, 4, 5, 6 and B is equal to 1, 0, minus 1. Now A has the order 2 cross 3 and B has the order 3 cross 1. Now number of columns in A is equal to number of rows in B. Therefore A cross B matrix is exist and has the order 2 cross 1. Now 2 is the number of rows and 1 is the column, which is C11 C21. Now let's calculate C11, which is multiplication of first row in A to first column in B, which is 1 into 1 plus 2 into 0 plus 3 into minus 1, which is equal to 1 plus 0 minus 3 is equal to minus. Now C21 is equal to multiplication of second row in A to first column in B, which is 4 into 1 plus 5 into 0 plus 6 into minus 1, which is equal to 4 plus 0 minus 6, which is equal to minus 2. Now A cross B is equal to the matrix minus 2 minus 2. Let's take fourth example, which is A equal to 1 2 3 4 and B equal to 2 3 1 0 1 4. Now A has the order 2 by 2 and B has the order 2 by 3. The number of columns in A is equal to number of rows in B. Means A cross B exists and has the order 2 by 3, which is C11, C12, C13, C21, C22, C23. Now let's calculate all these element one by one. Let C11 is equal to first row to first column, which is 1 into 2 plus 2 into 0, which is equal to 2 plus 0 is equal to 2. Now C12, which is multiplication of first row to second column, 1 into 3 plus 2 into 1, which is equal to 3 plus 2 is equal to 5. Now C13, which is multiplication of first row to third column, which is 1 into 1 plus 2 into 4 is equal to 1 plus 8 is equal to 9. Now C21, which is multiplication of second row to first column, which is 3 into 2 plus 4 into 0, which is equal to 6 plus 0 is equal to 6. Now C22 is equal to multiplication of second row to second column, which is 3 into 3 plus 4 into 1, which is equal to 9 plus 4 equal to 13. Now C23, which is equal to multiplication of second row to third column, 3 into 1 plus 4 into 4 is equal to 3 plus 16 is equal to 19. Now A cross B is the matrix with the value 2, 5, 9, 6, 13, 19. Now let's go to the next point. Matrix multiplication is not commutative. That is AB is not equal to BA. Let's take an example. Let A is equal to 2 1 matrix, which is 2 by 1, and B is equal to a matrix 4 5, which is of order 1 cross 2. Now the number of columns in A is equal to number of rows in B. That means A cross B is exist and has the order 2 by 2. Now to find B into A, where B is equal to the matrix 4 5, which is 1 by 2, and A is equal to the matrix 2 1, which is 2 by 1 matrix. Now number of columns in first matrix is equal to number of rows in second matrix. Therefore B cross A is exist and has order 1 by 1. Now A cross B is of order 2 by 2 and matrix B cross A is of order 1 by 1. Therefore A into B is not equal to B into A. Now properties for matrix multiplication. A, B, C are matrices and K is scalar. First property, Ka into B is equal to K into AB is equal to A into KB. Second property, A into BC is equal to AB into C. Third property, A plus B into C is equal to A into C plus B into C. Fourth property, C into A plus B is equal to CA plus CB. And remember that the commutative property is not true for matrix multiplication. A into B is not equal to BA. But for addition of two matrices, commutative property is true, which is A plus B is equal to B plus A. In the next video, we are going to learn transposition of matrix and vector or transpose of the matrix.